In this video today, I'm going to be solving simultaneous equations using row reduction, or we can refer to this as a reduced echelon. So, welcome to GMU. If you're new, please don't forget to subscribe. And so, let's continue. So out of that, this is a method of solving simultaneous equation, but basically it is a matrix method. So if out of this, we reduce, the matrices by obtaining the coefficients and then forming a matrix. So out of that, for a quick description of this, a description, a matrix way of solving simultaneous equations, especially 3 or more linear equations. So in this case, that we have, we are having ax plus by plus cz will be equals to L. So in this case, we find out that we're having, this is a linear equation. So you find that simultaneous equations, we have the unknowns like x, we're having y and z, of which there are unknowns in this case. So we have to find them using simultaneous equations, and therefore here we can notice that since we're dealing with simultaneous equations, so in this case we cannot only have only one equation. So out of that, we can see that now how does a simultaneous equation look like? So we're having this, we're having, let's say, 3 linear equations. So out of that, ax plus by plus cz is equals to L, and we're having dx plus ey plus fz will be equals to m. So gx and hy plus kz is equals to n. So these are linear equations, and therefore now to solve them we have to convert them into matrix form. So what we can see here, that we can extract out the coefficients. So they are the most that we need in this case in order to make a solution out. So out of that, the coefficients we look at, number that is in front of the unknown, of which in this case we are having a in front of x, and then we're having b in front of y, and therefore we're having also c in front of z. So we find out of that, when you're working out, we pick out the coefficients in order to bring out a matrix, of which in this case we're having 3 rows and 3 columns, and therefore it is a 3 by 3, and then we are having x, y, z. So we arrange them in such a way that if we multiply back, when we are multiplying matrices, that we can get back our, the general form. For example, having separate linear equations that will be forming our simultaneous equations. So the next, now forms of matrices that are involved. For example, we saw that, we're having this, but to identify this, so we're having this a matrix of coefficients, of which in this case we had a, b, c, l, then d, e, f. So we had to extract them out. So out of that, we're having a, b, c, and d, e, f, g, h, k, and those are the coefficients. And then we are having the matrix of the unknowns, of which we are having x, y, z, and we are having l, m, n as the matrix of the end operations, like the results in this case. So out of that, we find that for easy identification and for easy solving and making a solution of our working. So out of that, we find that now when we are solving, we have to form what we call an augmented matrix. So an augmented matrix is a matrix that's just an appended matrix. So out of that, we just use an imaginary bar to separate, the answers from the coefficients of the unknowns. So out of that, this is an imaginary bar, of which in this case I'm representing this by a blue bar, separating the answers from the coefficients. So this is just to promote easy operation without this like separation that would involve this like the unknowns between this the answers and they say that the coefficient matrix. So the next step here, we can see that when we are solving this, we have mostly our aims. So the first one is this like so majorly the row reduction is performed by increasing the number of zeros from left of the second row to the last row and second last row to the upper row and keeping the leading diagonal with 1. So after achieving this, that's when we say that we have achieved the reduced echelon, of which the reduced echelon is when you are having zeros here, we are having these zeros here, and we are having also these zeros down here, and the leading diagonal having only 1 each. Let's say 1 1 1 1. So out of that, that's when we say that we are so that the same having our matrix, having this like we work out in such a way that, for example, D G H, that it becomes 0. At the same time, we're having B C F becoming 0. So that's how we can receive this, like say that that's a reduced echelon. So the next one, let's like if you have an example, for example, one of the numbers that we can work out in this case. So if I have x plus y plus z minus 4, this would be equals to 0, and 2x minus 3y plus 4z would be minus 33 would be equals to 0. Then 3x minus 2y minus 2z minus 2, this would be equals to 0. So out of this is like we first arrange this in an order that we can easily work out, and therefore we find that the arrangement here, this like have xy plus z, so having this like the unknowns and the coefficients on one side and the answers or the end results on the other side. So in this case, I'm having x plus y plus z equals to 4, and 2x minus 3y plus 4z equals to 3, and having 3x minus 2y minus 2z equals to 2. So you find out of that, I've taken, let's say, the whole numbers that don't have, let's say, unknowns to the other side, and the ones with unknowns, they're keeping their coefficients on one side. So if we extract out the matrix, you find that it would look like this, that we are having 1, because 1 is in front of x, and we are having 1 in front of y, that's where you're having 1, and z is having 1, so this is just the coefficients. And then 2, 3, negative 3, so you take it with its sign, and therefore, and we're having 4 and 33. So we're having 3 here and 3 here. So if I out of that, then negative 2y, and we're taking only negative 2, then negative 2, and then a 2, of course. So we're seeing that the vertical bar is there, so this is an augmented matrix. And so, for example, if you're working out this, so what we do here, for example, I want to make, for example, 2 is 0 in this case. So out of that, I have to show the procedure of the operation. For example, like I'm having 2, of which in this case I'm having my 2 here, of which this is my 2, but I want to make it a 0. Therefore, what I do here is I'm going to say that 2 times 0 1 minus row 2. So what I do in this case, if I multiply 2 on row 1, in this case I'm going to get a 2 here. So if I multiply this by 2, I'm going to get 2. So minus the row 2, which is a 2, and therefore I'll be getting this is 0. So again, 2 times 1, I'll be getting a 2 minus a 3, which will be a 5. And so I write the 5 there with corresponding place, and therefore multiply 1 times, this is 1 times 2, and then minus 4. I'll be with a negative 2 in this case, which is this, and therefore I have 4 times 2, 4 times 2 in this case, which I'll be having 8 in this case, then minus 33. Minus 33, I'll be having negative 25. And so I go on to now, I want to make also 3 a 0 in this case. So what I do in this case, I'm going to say 3 times row 1, yes, because I see that this 3, if I multiply it by this 1 here, so I use this, for this case, I'm using row 1 as the reference because they still have the same number of figures. So figures are not yet 0. I've not just started my operation. Therefore, I've converted this to 0 and I have to convert this to 0 such that these 2 rows have been worked upon, and therefore for the next step I can take them for reference. But in this case, I'm going to be taking row 1 for reference in this case. So now let's make 3 is 0. So out of that, I'm going to multiply 3 to row 1, yes, 3 to row 1, then minus row 3. So if I multiply 3 here, I'm going to be having 3. So minus 3, I'm going to be having a 0 in this case. So I'm going to multiply 3, of which I'll be having 3 minus 2, which would give me a 5 in this case. And so if I have, this is 3 minus 2, I'll be still be having a 5. And so if I have 3 times this, I'll be getting 12. So 12 minus 2 in this case, I'll be having 10. Yes, so all of that, this is our first successful step, of which we have got 0 as in our first operation. And therefore for the next operation, we want to make the 5 this a 0. And so if, let's say for the next step, let's make the 5 a 0. In this case, we are going to be saying that now we can take now row 2 and row 3 into consideration, but initially we could not take them into consideration because we had to use the first row for reference. So we choose one row and then we use it for reference, but especially we mostly use row 1 in this case. So out of that, I'm going to say that row 2, yes, row 2 minus row 3. So we find that 5 minus 5 gives me a 0. So then negative 2 minus 5, this would give me a negative 7 in this case. So I'm having negative 7. But remember, let's say the one you use for reference, you always keep it constant. You don't tamper with it. And so that's what we're doing here. So we find that we're taking row 2 for reference, but we're not tampering it with its values. And therefore, so next one, let's say this, we have got negative 2 minus 5, of which we have got negative 7. So negative 25 minus 10, you get negative 35. So that's why we are having negative 35 in this case. Now, the next thing is now we want to now remember we are working out such that we get, let's say, like the matrix reduced into echelon. So out of that, we now, the next step, we have to work hard. Let's say we get, let's say, these to become zeros. To become zeros. So what I'm going to do here, after highlighting them, which of course this, like, you have been knowing which ones you work, the values that you're working with, actually they're elements. So out of that, this will give me something that would be, I'll start with a 1 in this case, and therefore if I multiply this, like now I'm taking the R2, for example, row 2 and row 1 as my reference. So out of that, I want to make 1 a 0 in this case. So remember, these are the elements that I want to make zeros. So I'm having 1 and negative 2. So out of that, that means that to make this 1 a 0, that means that I have to multiply a 5 here, multiply a 5 here so that it becomes a 5, and therefore when I subtract I get a 0. But since I'm using this as for reference, but I'm aiming at making this a 0, so that means that I won't tamper with this. So out of that, if I say I write the operation here that I'm going to be performing, of which this would be 5 R1, so I'll be having 5 minus 0, of which I'm going to be having 5 still, but keeping this constant. So out of that, I'm having also 5 minus 5, I'll be getting a 0. And then I'm going to be having, this is 5, yes, 5 minus 2, which will give us a positive 7 in this case. And though I'm going to be having 20, because 5 times 4 we get 20, minus 25, that would be a positive 45 in this case. So therefore we have successfully made the 1 a 0 in this case. So the next step we are going for this. Now we have to, now the one that you had in the previous step, let's say you had a 1 here before converting 1 to a 0, but now it changed to 7. That means that you still have to work all the elements within that position so that you make it a 0. So that's what we are going to be doing here. So that it's like, now I want to make this a 0, but now one that I can use for reference is, let's say, like I'm going to be using, let's say, R3 and R1 very quickly. So out of that, this one, now if I say 5, for example, 5 plus 0, I'll be remaining with 5 still, yes. So but remaining with 5, then 0 I'm having here, 0 plus 0, I'm going to be having 0 still. Then 7 plus negative 7, I get 0 still. Then 45 minus 35, I'll be remaining with 10, yes. So now 7 has been made a 0. All the element within this position has been made a 0 successfully. So the next thing is that we want to make now this negative 2 is 0. So out of that, we mark it such that we don't forget it. And therefore, so we have marked it with red. And therefore, to make this a 0, now I can take that, let's like, since row 3 and row 2 have, it's like, the zeros at the beginning. So that means that I can use both of them in order to make the negative 2 is 0. So if I'm now to make this is 0 without tampering with R3, that means I'm going to multiply 7 up, then minus 2R3 in this case. So out of that, if I come here and say that I'm going to be having 7R2, that means I'm going to be multiplying throughout. And therefore, this is going to be 7R2, of which 7 times 0 minus 0. Of course, I'm going to be getting 0 here. Then 7 times 5 minus 2 times 0. So that means that here I'm going to be getting 35 in this case, which is here, of course. So then these two will be giving us zeros. So that means that we are going to be having 0 right here. So if you have 7 times negative 25, of which this is 7 times negative 25, I'm having negative 175. Then we are having minus, we're going to be having, this is 2 into negative 35. Of course, we're having negative 105 in this case, which is right here. Yes, so out of that, having got that, but we have not tampered with the third one. So we are looking for values of x and y, of course. Now, in reduced echelon, we have to divide these throughout. So divide throughout by 5 and divide throughout by 35 and divide throughout by negative 7. In that case, we'd be having 1 in the leading diagonal, and for the next would have, let's select our answers. For example, for x we would have 2, and for y we would have negative 3, and for z we would have a 5 in this case. So if I'm out of that, this is how we solve equations using this the row reduction method. So thank you for watching. Don't forget to subscribe. See you next time.